So we need to use techniques of gamma function to show that the given integral is negative 1 raised power k times k factorial. So let's check the solution. So we have to show that the integral from 0 to 1 ln of y power k dy is given by negative 1 power k multiplied by k factorial, where k is any natural number. Now, to be able to solve this, we make some substitution. So we let u to be ln of y. So which means that du is 1 over y dy. So which means dy alone will be given by y du. And then remember, if we say u equals to ln of y, this is in logarithm form, then this statement has the same meaning as y equals to e raised power u. Remember conversion from logarithm form into index form. So this will be the same as e raised power u du. Now, integral, once we have that, let's see how the limits are changing. For limits, so when, remember these are limits for y equals to 0, then ln of 0 is infinity. Which is u is infinity. And when y equals to 1, u will be ln of 1, which is 0. So limits change. So therefore, the integral from 0 to 1 of ln of y power k raised power k dy will be given by the integral. Now, 0 will now be infinity, and then 1, 0, u power k dy is the same as e raised power u du. So therefore, this, so remember the limit here, ln of 0 is negative infinity. So this negative infinity. So then we have now, let's call this one 1. So we do another substitution. We are going to do another substitution because this first substitution has given us an integral that doesn't conform to the structure of the gamma function. So in the new substitution, we let negative t to be the same as u. So remember ln of 0 here, this negative infinity. So which means negative dt is the same as du. And remember, these are limits for you. So when t, okay, when u is negative infinity, this implies negative u will be the same as positive infinity, so which is the same as t. And then when u is 0, then t will also be 0. So therefore now integral 1 becomes, so this to mean that limits change. One becomes the integral from now, where this negative infinity, I have positive infinity, 0 remains to be 0. And then u is the same as minus t. So I'll have minus t power k. And then where I have u, I replace by negative t. So I'll have e raised power negative t. And then du is the same as negative dt. So once I have that replacement, this will give me, I can factor out, say, negative 1 integral 0, infinity to 0 of, remember, this can be written as negative 1 power k, and then t power k, and then e raised power minus t, and then dt. Because I've factored out this negative. Now, remember that from basic integral properties, integral from a to b of f of x dx is given by, if I say negative, then I'm allowed to change the limits from so when you introduce a negative sign, then I change the limits. So I will do away with this negative sign by simply interchanging the limits. Lower limit become the upper limit and vice versa. So this is the same as now 0 to infinity of negative 1 power k t power k e raised power negative t dt. Now we can rewrite this out because these are constant, then factor it out. So say negative 1 power k integral from 0 to infinity t power k e raised power minus t dt. But you see, we can write this power. So if you say n minus 1 equals to k, so then n alone will be given by k plus 1. Okay, so this power can be written as, or this integral can be written as negative 1 power k integral from 0 to infinity of t raised power, say k plus 1 minus 1 e raised power minus t dt. And this is the definition of gamma of k plus 1 And gamma of k plus 1 is the same as k factorial. So therefore, the integral from 0 to infinity, 0 to 1 of ln of y power k is given by -1 power k times k factorial. So this is the proof of that given equation. So remember, at this point, we have just used the fact that gamma of x plus 1 is given by x factorial. So this is the property that we have used to change, to move from this point to this point here.